my name is Nathan Maynes, and I work for Thomson Reuters Special Services. And today I'm going to share a handful of lessons learned from trying to build and manage a knowledge graph. And so you can kind of think of it as things that you should, learn from my experience and learn how to do, and then also things that you should definitely not do if you're ever in this situation. Okay, so just to kind of introduce the scale and scope of what we're dealing with is, well, the current knowledge graph that we maintain is currently indexing 74 different data sources. Those could be as robust as the organization and people authority that Thomson Reuters maintains for its Wall Street traders. And they could also be as small as custom delimited files that an individual may make and manage and wants to upload every once in a while. We store these at the base layer in RDF triples, and so we have over a billion. We're closing in on 2 billion, and that represents over 18 million unique entities. And this whole stack is supported by at least 7 major open source projects. Many of them we've heard talks on today: Solr, Hadoop, NiFi, and then a bunch of other kind of personal favorites like Apache Calcite and some other ones. And so the question that naturally comes up is, why in the world would we do this? Why would we go through all of the trouble of reading in data sources as disparate as spreadsheets, relational databases, and kind of enterprise graph feeds? And the answer is fairly simple. We try and serve a number of different users and use cases, and we want to put all of that data in a format that can be useful to them and is flexible enough that we don't need rigidly defined schemas to answer questions that naturally come up when investigating a whole bunch of different areas. So I'm going to walk through an example here of kind of a high level, something that we were tasked with doing and what we ended up doing and what we learned along the way. So behind me is just a screenshot of Reuters Connect, which is a visual interface to connect to all of the Reuters media content. Now this is news that you may see repackaged by some other news provider, so like the Washington Post or New York Times, but it also includes a whole bunch of news that never makes it in front of a reader or a news kind of junkie, no matter how junky they are. What I mean by that is included in this is a whole bunch of low latency, what they call machine readable news. This is the stuff that trading firms will pay a lot of money to get, basically 20 characters on whether or not PepsiCo hit their earnings statement for the quarter. That's all included in here, and we need a way to manage the really small news that you and I may not look at and consider an article, but Reuters does. It also includes videos. It includes images. And a lot of those things are not good candidates to be shoved into a graph. They may be interesting in an application, but in terms of structure and just making sure we have people, places, and things linked together, they're not super useful. So what we end up doing is processing somewhere around 16 million chunks of content a month, and we filter that out, and we make sure we bring in, through a series of kind of logical just decisions that we've made, only content that's going to enrich and feed the graph that then in turn serves a handful of use cases. Like I said, this is quite a few items every day, but this isn't something that's going to scare anybody in this room, right? We're talking 16 million. That's not mind-blowing anymore. But what is interesting about it is how different everything is. It can be text, video, or image content. And we've got to do something with that, because a lot of times it's not structured. And that's where our whole pipeline comes in, right? This is where we start leveraging a lot of great open source projects and kind of combining it in an interesting way in order to support this workflow. So the high level of what we do is we bring things in and we map it, and then we stitch it together, and we tag it, and finally we index it all so that you can search it. And what that means is that in the mapping stage, what we're trying to do is unify all of the data and the attributes into a common vocabulary. Some people may call this an ontology, and we manage a handful of ontologies to talk about the world in different ways. One of my favorite quotes is that, all data models are bad, and some of them are useful. And that's what we're trying to do here, is build a handful of useful data models for looking at the world so that we can represent them in a manner that users can actually do something with. Then we get to the stitching piece, and this one will glaze over, even though it's one of the hardest parts. This is where we take entities in the world, like Donald J. Trump, and we resolve it to the appropriate thing. So when I say that word, a lot of people will think of a person, perhaps a political office, but you may also think about a company or a series of companies. And all of those things are unique and exist in our universe. And we need to model and disambiguate to all of them. And we need to do that in a sensible way so that we're not tagging things that should be related to the company, Donald Trump, to the person. Once we do that, right, once we've kind of established our stitching rules and guidelines, we start to tag everything that exists in the graph according to those rules. And we do that with structured and unstructured data. So that lets us leverage a lot of work that's being done at, say, Reuters or other commercial fee-for-service data providers, but it also lets us use natural language processing to find instances of the company Boeing and create a relationship between Boeing and a document. Finally, we load all of that in and make it searchable in Solr. And we use Solr's search capabilities to allow users to use free text instead of write really long Sparkle queries. So if any of you are in that linked data space, Sparkle is very powerful, but it puts a lot of people off, especially if they're coming from even a SQL background with its syntax. And so we do this in Solr, and you can leverage Lucene syntax and just free text in general to find things in the graph that are going to be interesting and make the connections that will be valuable. Our overall architecture diagram looks like this, right? At the bottom, kind of in our storage layer, we have Hadoop, Zookeeper, and Accumulo running to keep all of the raw data, the triples, and then manage the traffic. At the kind of the middleware layer, we're running Solr, Postgres, Redis, and a bunch of connectors and web UIs. And we serve that all up either through a browser application or via an API with endpoints that allow you to traverse the graph. So it's all great, but it needs content, and we need to load it. And that's where we get to leverage one of my favorite open source projects, Apache NiFi. Really quick, for those of you who don't know, Apache NiFi is kind of a data flow management tool, and it allows you to consider data and individual pieces of data as just pieces of information and build rules around how to process that and move that around because you don't have infinite compute resources. And so you want to be able to structure it so that you do the things you need to do right away, you do those. For some of the jobs, like loading in a giant batch of news, you do that when you have time and resources. And so we use that to manage all these different data sources that we're ingesting into the graph. We'll use that, and it's really helpful for the data that comes in on different schedules. So some stuff that we have comes in on every few seconds. We'll get new content. Other sources that we ingest are quarterly or yearly, and they're large, but we don't need them in right away. And NiFi helps play traffic cop for us in managing that flow of data. So some of the favorite things that I like using in NiFi, I use the Apache calcite record querying, and that allows us to leverage, some of our traditional data warehousing team members and leverage their knowledge of the data sets where they can write SQL, and we can manage and maintain that within NiFi. I use the Jolt-powered JSON transform a lot to process large JSON documents. And finally, I use Apache Avro to convert a lot of data into a record-oriented format so that it gets a lot less verbose in terms of a data flow, and we can manage it directly in a compact and uniform manner. And so what I want to do with the last couple minutes we've got here is kind of go through a handful of use cases after we do all this work to get things in that format and get it in a standard graph setting and scenario. We support a variety of use cases, and I'm just going to go over a couple of interesting ones to get your minds thinking, right? This is something that you can do, and you can download a number of the data sets that I'm going to talk about without paying for them. They're open and available on the web. So one of the interesting projects we did was we went and looked at whether or not we could do relationship validation via automated document tagging. So you'd take something, you'd take a recent news event, for example, Boeing's recent controversy with the 737 MAX plane, and we start feeding news in, and we tag all the entities that exist inside those documents. And we start to see that perhaps Boeing and Ethiopian Airlines had some kind of relationship before, and a spike happens when some kind of controversy in the world occurs. And so what you'll see is all these documents will just flood that relationship, and you'll get kind of this, I like to call it the buzz score, but you'll get all these documents that link between the two, and all of a sudden that relationship becomes a lot more relevant to our use case. We also try and do that over time, so we take a slice and we can move it, say, in weekly, monthly, quarterly increments, and you can watch as the relationships in the world between people, places, and things kind of ebb and flow. And that allows you to do some really interesting graph centrality algorithms to figure out who currently is an important player in a particular industry or within a particular company. Another interesting use case that we've used this for is we've done something similar with investment data. So we take documents that talk about where companies, investment firms, hedge funds are pouring money and resources, and we extract relationships and entities from those. And then we also take structured data that we have that allows us to identify deals, joint ventures, and other things between companies. And we map that to a geographical space. And so what you see here is a heat map, and this is investment and by dollar amount into a Russian mining company. And so this wasn't necessarily something that we were out looking for, but by doing all the work to get the data in a specific format, what we ended up discovering is if you look at that heat map, you have a really big bright red dot on Florida, which is really strange when you consider that Wall Street is not in Florida. Usually we see a lot around New York and California, London. But in this case, Florida is really by far and away the biggest investor in this company that we know about. And so this was sometime almost a year ago when we did this exercise. And later in that year, news started coming out where these retirement funds were pouring money into these sanctioned Russian companies. And this was just something that basically I thought we were wrong. and I thought that I had more work to do when I looked at the data because it didn't make a lot of sense, but it started to come out, and this is still something that people are trying to get to the bottom of. Other things that are really interesting and relevant, right? These are things that you can, I like to use them at dinner parties. They're my dinner party examples because perhaps you have been driving around town and stopping, traveling to conferences, and you have to stop at a place like McDonald's for some food. And you wonder, you kind of scratch your head when you notice that everything on the McDonald's menu has bacon on it. Well, this goes back to how we look at and identify risks and opportunities within a supply chain. So this particular example is interesting because it leads to a very real question that many people may have, like why in the world is there a big push for bacon by McDonald's? And what we do is we take a lot of that information that, again, structured and unstructured, we bring it all in, and what we're able to identify is that there's a pretty strong correlation between the tariffs levied by China and Mexico last year against U.S. pork providers that drove the price down significantly, and McDonald's swooped in and bought up a whole bunch of pork futures. And so now what that means for you as a consumer is you have a ton of bacon options on fast food menus. So basically, lessons learned from all of these things, right? This whole exercise has helped me learn a number of things about how we work with data from disparate data sources, especially when we want to put it in a graph. The key takeaway is really let the questions drive the model. Work with people that are going to be using the data, understand the kinds of questions they ask, have them write them out on paper, and help model that in your backend so that it can be useful for the front-end users. If it doesn't make sense, this one seems really basic, but there's a lot of things that have been said at the conference that are really basic, like patch your software, read the docs, those kinds of things. If it doesn't make sense, don't do it, right? Don't try and shoehorn things into your data model that just don't make any sense. Another one that I struggle with when I'm dealing with customers, both internal and external, is big data is not always useful. Sometimes too much data can drown out really useful information and make it harder, even with these surfacing techniques, to find things that are going to, be able to wow a user. Make sure you test assumptions first. Test things on a small subset of your data before you dump everything else in there. And then also plan to make mistakes. It's totally okay to do that in this scenario as long as you plan for not being perfect. If you go in there thinking that you're going to be perfect and everything's going to come out exactly like you envisioned from the get-go, spoiler, you're going to be in a world of pain. People will ask you questions like, why does it look this way? Or why is it taking you so long? Or why is there so much garbage in here? So plan to make some mistakes and incorporate that into your plan when you're building a knowledge graph pipeline. And so with that, I have a few minutes for questions.
Yeah, a few minutes for questions, absolutely.
Great. So with that, that's my presentation, and I'd love to take a couple questions if there are any.
Are you planning to commercialize? It seems like you know the trend. Looking at the data, and it's interesting, you said, oh, that can't be right, this whole investment in Florida. Is there any plan to commercialize that or offer that to, trading firms, hedge funds, anybody like that?
Yeah, so we do have certain commercial offerings around some of these use cases for our customers. And then some of it is just interesting to me, right? It's like stuff that we go to like meetups and talk about, and everybody's like, oh, cool, McDonald's bacon. That's interesting. But yeah, we do support, a lot of this is driven by requests from customers. Please.
Do you guys explore any other open source technologies like Point for the streaming side of it, as opposed to what you mentioned, or like the streams or?
Yeah. And that's a really good question because we're kind of continuously exploring different pieces that can plug into this. The question was, have we explored other kind of Apache projects, right, to plug into the pipeline, especially around streaming? And so one of the ones that we've looked at is Kafka and implementing kind of a streaming time series to help support our streaming time series analysis. That's one that we've looked at, but we haven't implemented it yet.
All right, one more question. Anybody?
Why did you select the Cumulo as your backend data store instead of a more widely used platform?
Interesting. One of the big pieces is the cell level encryption. I know that's like not that great, but that's the answer.
All right, can we give a round of applause for Nathan?